Hello, it's receiving students and teachers. Thank you. You may be seated. Our lesson, we're still looking at the strand, science in the ohm, substrand using energy in the ohm, and outcome 8.3.3. First of all, before we go on to today's lesson, let us recap on what you did in the last lesson, in the previous lesson. What was the topic of the last lesson? Receiving students, you can tell your teacher the topic of the last lesson. Let's have Edward to tell us.
Sources of energy.
All right. The topic of your previous lesson was on the sources of energy. When we look at sources of energy, let's take an example. You come to school, you work, and you play. You work and you play because you have energy. Now, where does that energy come from? All right. The source is the food that you eat. All right. The food that you eat. All right. You see a vehicle traveling. What is the source of energy in that vehicle? The fuel. All right. Those are the source of energy. You see a torch that contains battery. It gives off light. What is the source of energy in there? Battery. But if we look at battery, we look at the food that we eat, we look at the fuel, they also come from one source. And most of these energies that we see, they have a principal source of energy, and that is the sun. Sun is the principal source of energy. All right? Most of the energy comes from the sun. Our lesson topic for today is measurement of heat energy. Right? Now, these are some things that we will have to go through in our lesson. We will try to find out how it can be measured. Right? So, how can it be measured? In this lesson, we will try to find out how we can measure it. So before we go on to that, we will try to identify and discuss how heat is applied in these following pictures. Receiving students, you can discuss with your friends. I will show you a few pictures, and you will try to discuss and identify how heat is applied in these pictures. We see an industrial area, all right? Could be a factory. Tell me what you see that can tell you that there is heat being used. Talk it over with your friends. Okay, let's have Anna. Tell us something about this picture.
There's smoke coming out of a factory, maybe because there's machine that consumes a lot of energy.
Machine that consumes a lot of energy. All right, it uses the energy, and maybe while using the energy, it releases those the smoke that you can see there. All right, so in fact, there is heat being applied. Maybe in the machines, fuels are being used. Let's have a look at this one. Talk about it. What you can see there. We'll have Bobby tell the class something about this picture, how it is applied in there.
When we add more wood, the wood contains chemical potential energy, and that's when the fire gets big.
Okay, good. We can see that there is a fire. What is this fire used for? All right, for cooking. Now, there is heat energy being applied there. We can see that there is firewood. It contains chemical energy. When it's burned, it gives off heat and light energy. All right, so it's used for cooking. All right, the next picture you will see is the picture of the sun. All right, there is so much heat and so much light energy coming out from the sun. All right, we have seen that much of our energy is from the sun, but in actual fact that there is a lot of heat being released from the sun. Last one. You can see a boy riding a bicycle. Try and tell your friend where you can see, where you can identify heat energy being released or taken place in one of those areas there. All right, we'll have Messi. Messi, tell the class, where do you think heat energy is been applied, or heat is applied in there?
Heat energy is applied around the pedal.
Applied around the pedal. Okay. Good. Any more? Any more? If you look at the picture carefully, you will find that it is applied. It can be between the pedals and the leg, but much of it that is produced is between the tire and the surface that the tire meets. All right. So there is what we call frictional energy taking place. When there is friction, when friction takes place, there is always heat produced. So it is around there. Now the first picture we looked at a factory. We found out, we tried to mention something that machines do work and give off the heat, all right, use of fuel. Second picture, we looked at firewood, all right, being burnt, giving off heat. And we looked at the sun, and now we're looking at a boy riding a bicycle. Now the question may be, we have discussed something about the heat, all right? We can say the boy riding the bicycle, there is heat between the surface that the tire meets. But how hot is it? We're trying to look at the heat. Looking at the sun, how hot is the sun? Looking at the fire that we try to make in order for us to cook the food, how hot is the fire? How hot is the machine that uses up the fuel? So that leads us to the question, how we can measure heat? How can we measure heat? So in this exercise, or the experiments that we will carry out, we will try to find out how we can measure heat. I'd like one runner from each of the groups to come up, please. To get one. Receiving students and teachers, these are some of the things that you should have. We have a container of water, a kerosene burner. There should be 2 beakers, a med gauge, tripod stand. We have a candle, a matchbox, and there should be one methylated spirit burner. Right. Firstly, listen everyone. We will be working with fire. Our safety should be the priority, all right? I don't want to see you playing with fire. you follow instructions very carefully. Make sure when you are lighting the burners, you put whatever the papers and other things away. So we'll quickly go through the instructions, very important. This is what you're going to do. I'd like you to listen. Instructions for the experiment. Number 1, it will predict what will happen when the temperature of heat water from different sources are measured. All right? So it will make a prediction. And number 2, it will also give reasons for your prediction. So first part of the activity, you will have to predict. Receiving students and teachers, the experiment that will be carried out, the activities or the instructions are this. First, set up the equipment. We have the tripod, so you will stand it. And so this is the tripod. You will stand it. And then you will put the med gauge on. That's setting up the equipment. It will measure 50 milliliters of water into a small beaker. It will use this receiving students. If you don't have a beaker, maybe you can use measuring cylinders where you can pour water into the measuring cylinders up to 50 milliliters. And if you don't have a beaker, you can use a can. For model class, this measurement of 50 milliliter on this beaker, so you will get the water from here and pour it into the beaker. And then you will record the temperature of the cold water using the thermometer and then remove the thermometer. We have thermometers. 8 you have thermometers there. There are thermometers containing mercury and alcohol, but in this case we have thermometers that contains alcohol. So we will be using thermometers that contains alcohol. And then you will place the beaker on the gauge on the tripod. You will light the burner and place it under the gauge so that the flame just touches the underside of the gauge. You get the burner, 50 milliliters of water, you put it on here. Before you light it, what do? After you put the water in the beaker, what do? You get the reading of the temperature of the water, all right, which is not been heated, all right, the cold water. So you get the temperature of the cold water. And then you light the burner and place it under the gauge so that the flame just touches the underside of the gauge. You heat the water for exactly 2 minutes. So we will start together and then stop together. After 2 minutes, you will put off the burner. Then you will measure the temperature of the heated water by putting the thermometer inside. All right? And then you will record the result. Now, receiving students, if you don't have the worksheets with you right now, then you can get this temperature result table into your exercise books. So get this done before we can start. How many? Only one.
This one more.
Yeah. All right, let's set up the equipment. Set it up. Someone set it up. Someone pour the water in the beaker up to 50. you predict your prediction. We are going to use three different burners. One is going to be with kerosene burner. Another is methylated spirit burner. And the other is candle. So you predict with kerosene, with the methylated spirit, and with candle. If you apply that heat onto the water, what's going to happen?
So we can put a banner inside.
You got your predictions done already? Yes. Already done? Yes. All right. Then we shall start now. You got your reading already? Yes. All right. You can get your reading now and record it. All right. First source of it that we will use, let's start with methylated spirit. Your banners, you can put them on the...
Methylated spirit.
One more minute.
One more minute. That's why I put it last. They did. They did. Okay, 2 minutes now. What you do, you blow it out and put a thermometer inside the water and get the reading. Quickly put the thermometer in. Put it in and leave it, and you take your reading. Is it rising?
Yeah.
Where it stops, you take that reading and remove it. Because if you leave it, it's going to cool and the temperature will change again. You get the beaker away and pour new water into the other beaker. Yeah. All right, next one we will use the candle. Candle. Before we light it, what are we going to do? Get the temperature of the cold water. The other beaker that you have used, you can pour that away. The new one, you get the measurement first.
Thank you.
Where's your candle? Just a minute. You all ready? You got a reading already? All right. You can light the candles now. Quarry and your group, we're still waiting for you. All right. You may start now. Can.
Pasiantan. Pasiantan.
You got 1 more minute. No, you can put it down. Put it down. Put it down. Put it down. All right, blow the candle out. Quickly put the thermometer inside. All right, you got your reading? After you take your reading, you remove it. Is this new water?
26.
New water.
Yeah.
You used this one already?
Yeah.
New one.
No, reading 25. I just said 25.
25.
Okay, after you do your recording, we will go on to the last one. All right, you take the reading of the cold water. Now, for this activity, for the kerosene burner, I decided to put it the last one because it has a lot of fumes. So, if you think that you are not capable of not capable of getting these things in, the fume especially, which might give you some problems, then I do allow you to go out. Right? You already took the measurement,
Yeah. 26.
the temperature. Okay, we will begin now. All right, I believe you have all got your readings now. We'll have two groups to tell us the results from the table and we will finish off from there. Let's have Ellen. You tell the class your findings, and we'll have Karot. You will get ready to tell the class your findings. I know others, you have your results, but we'll have only 2 groups to present their findings, and we will stop. So let's have Ellen to represent your group.
My group and I did our experiment, and we found out that the temperature for both the 3 of the source that we used, they were like all level like 26, 27 degrees Celsius, and the temperature for the heated water candle was 35 degrees Celsius, methylated spirit was 36, and kerosene was 49. So the most source that produced the more heat was kerosene with 49.
Okay, according to them, it's kerosene that produced the most heat. All right. Now they will have to also give their reasons. All right. There are 2 questions that you will find. You will also answer us, explain why you think kerosene gave the most heat. All right. Let's have the other group. Karau. You others listen.
Okay, the heated water, 32 degrees Celsius. 32. Okay. Temperature of heated water when we put it under the candle, 34 degrees Celsius. Kerosene, 38 degrees Celsius.
So which was the most heated?
The most heated one was the kerosene.
Kerosene. All right. Also give you reasons. So we have looked at the 3 source of heat. We looked at a methylated spirit burner, kerosene burner, and the candle. So according to these 2 groups, they said that the kerosene burner gave the most heat. Why do you think? Why do you think that kerosene gave the most heat? I hope you also have the same measurements or readings. All right, let's have Tulanga.
Because kerosene had bigger chemicals
Bigger chemicals.
and bigger flames.
Bigger flames. Okay, good. Let's have Messi.
Because kerosene produced the biggest flame among the 2.
Okay. According to Messi, kerosene produced the biggest flame. All right. Maybe there are some reasons why kerosene, maybe it was so close or the flames were too big. All right. But there are some reasons why your findings were like that. But anyway, today we've tried to find out how we can measure heat through those 3 different sources of heat that we carried out. These 2 questions, which you have already answered now, which heat source produced the most heat and which produced the least. The most heat produced was by the kerosene, and the least was the candle. All right. Explain why this happened. All right. Some explanations were given already. Receiving students, you can discuss that further with your teacher. Our summary, you can get this down. Point number 1, heat is a form of energy that can make substances hot. No substance will become hot if there is no heat. So heat is a form of energy that can make substances hot. So if you feel something and it's hot, you must know that there is always heat. When energy is given to a substance, it usually gets hotter. point number 2, there's a word missing. When heat energy is given to a substance, it usually gets hotter. If heat energy is removed from a substance, it usually gets cooler. Temperature is the measure of how hot or cold an object is. Thermometer is the instrument used to measure temperature. Right, the unit used for temperature is degrees Celsius. Right. Our keyword is temperature. With that, that is the end of our lesson. Thank you, HCs, resident students, and teachers for your participation.